Hello, Nandika, can you hear me? Yeah, good afternoon. Is the voice clear, Nikhil? Okay. Rohan, can you see the slide? Just type the heading, first word of the heading. Yeah, collision resolution. Very good. Okay, good afternoon to all of you. We were at collision resolution. Now, in previous class, what we have covered is that what is collision. As you know, that the key is passed to a function, and that function returns a index of an array. And if at that array index, if already a linked list is existing, then at that linked list, uh, if you have to add, you cannot add another linked list by overwriting on this linked list, but you have to append to this, right? So if the collision has occurred, means the index number is common for two keys, then the collision arises. So when the collision arises, we just cannot say that sorry, there is no place in the array list array, and we cannot accommodate this particular key. So what we need to do is that we need to append a node at the end of the existing linked list, right? The fact that we have to add at the end of the linked list, so there is no order. Unlike the order in the sense, unlike your skip list, the moment you have to add an element in the linked list, that element has to be at a sorted place, right? But here we are not doing the sorting job. We are simply appending at the end of the existing linked list. If there is no collision, means what? At that array index, the linked list does not exist. Since the linked list does not exist, we can simply add at that particular array index another linked list, right? So this concept of collision resolution is called as open hashing or separate chaining, right? In the under the open hashing heading, separate chaining is what the collision resolution technique is. So open hashing is a collision avoidance method which uses array of linked list to resolve the collision. Hash table, the hash function does not resolve the collision. As we saw in the previous class, the hash function simply gives the index, right? It is helping you to come to a particular index in an array, but if already existing linked list is there, it cannot resolve that. So to resolve that, there are separate different techniques. One of the techniques is called as open hashing, and the example of that is open chaining. And in open chaining, we start appending a linked list. So what we are going to handle today is the collision resolution. What we had handled till the previous class was a hash table, a hash function resulting into an index of an array, and the linked list is supposed to be there at that particular array index, right? The possibility of collision cannot be avoided up to here, but there is a possibility. Like other day when we had carried out a discussion, that in that discussion, suppose I increase the array size to a huge array size, then some of the students have very correctly said that even if you increase it to a huge size, the possibility of avoiding a collision cannot be negligible, right? Since it cannot be negligible, there is a possibility of collision. So if when the collision arises, we have to resolve the collision, right? So it is also known as separate chaining, right? Open hashing is also known as separate chaining. Why it is given this name? Each linked list is a separate chain. Each linked list is a separate chain. And let me go little further to the basics. We started the basic purpose of the basic building block of unit 2 is dictionary. In the dictionary, there is for every set of keys. The moment I say set, the uniqueness comes. For every set of keys, there is a corresponding value, and this helps in fast searching, inserting, and deleting, right? So that is our basic thing. The dictionary concept we are going to continue. Only thing is that the data structure of using that linked list dictionary concept is little different in this separate chaining. Let's see one example. There are division, percentiling with a number is a very common kind of technique of hash function. So let us assume that the table size has 3. Now, in other class, when I said the division factor depends on what? Any one of you who is listening carefully? The division factor depends on what? Size of an array, right? Good. Very good. Size, length of an array. Very good. Yeah. So good. So you guys are connecting what we have already covered. Thank you. Thank you, Bhavana, Vishnudeep, Nikhil, and others. So we are making an assumption, just for an example. Just for an example, we are making an assumption that the table size is 3, means that the array size is 3. So the percentile division is by 3, right? Then the array of the linked list will be, means what? Initially, when we are not added a single key, when we are not added a single key at all, right? The so far we have not started populating this particular hash table, right, in the collision resolution kind of a data structure. So what we need to do, we need to initialize what? Initialize this array, initialize this array, right? So let us see what is this array. Then the array of the linked list will be, at index 0 you have null, at index 1 you have null, at index 2 you have null. Since the size of a array is 3, therefore the possible values are 0, 1 and 2, right? So we need to first write a function after we enter the main. After we enter the main, we need to write a function which will do this initialization job. So having done the initialization job correctly, then only when the request comes to add for a key a value, there's a dictionary for a key a value, then again we have to percentile that particular key with 3 and come to one of the 3 possibilities, 0, 1 or 2. And wherever it hits at that particular point, we have to add the linked list, right? So initialization of each list to null, right? Each of this array we have to first initialize to null, giving an indication because we are presenting a menu to the user, and the user says 1 to add a key, 2 to say search a key, 3 to delete a key, and 4 to exit, say, right? So you have not inserted a single key, and the user may go for 2 option, which is a search option. In that search option, he may give you some key number, right? And though we know it fully well that at the present not a single key has been inserted, but you can't stop the user from doing some naughty things, like without a single element in my open chain, without a single key in my open chain, let me see what happens if I search. So if he hits 2 options and he gives a key, right, for that particular key, index will come here, here or here. Assume that the index has come to 1, right? So when the index has come to 1 and if it is initialized to null, we can put some kind of a if condition. If at chain of 0, chain of 1, if it is null, we can say the key does not exist. So keeping that in mind, keeping that particular thing in mind, initialization of this array is very, very important. Initialization of this array to null values is very, very important. Now see the logic, right? Now what logic I'm showing you on top right of your screen is exactly what it is there in my code, right? So when you start reading the code, it is not going to be a shock. What is that code and what is this resent, right? It is going to be exactly same. So you can link it up. Now let us see when I call this. First let's understand the structure of this and structure of this, right? So what you are seeing it over here is struct array items. Now what is here? Struct node head, right? This struct node head is a pointer pointing the first element of the linked list at an index of hash table, right? The head node, the element head, which is a pointer of what? Struct node type. So here I replace this with a kind of a at array chain of 0. I have a structure like this. in which there are two elements. The first element is the pointer head and the second element is the pointer tail. The pointer tail points to the last element of the linked list at an index of hash table. So at 0 I have one linked list, at 1 I have separate linked list, at 2 also I have a separate linked list, right? So here I have two elements, one which is pointing to the head of the, that is the first element, first node of the linked list corresponding to chain of 0, and tail is going to have the base address of the last element in this linked list, last element in the linked list. Okay, so at this particular point I have a pointer head, right, which is going to have some value, which is what is the value? Because it's a pointer, it is going to have the base address of what? Base address of node. So obviously this is an example of what? A structure within a structure, a structure within a structure. So there should be some definition of struct node. Obviously there has to be some definition of struct node. Are you clear about this head and tail? So this head initially and the tail both need to point to null. This should happen here, here and here. This should happen here, here and here. And what is this struct node? This struct node has got three elements. One is for the key, other is for the value, and third is for the next. Students, are you understanding? Is there any clarification required? I'm sure somebody will have some doubt. So those who have doubt, please use this chat window. Let us interact, because yeah, I'll repeat Vagara. Yeah, I'll definitely repeat. Harihara, it is like this. What? But before that, what can you visualize the structure of this struct node? Can anybody write the? Yes, Rohan. Let Rohan take it on. Put it in the chat window so that it will help others also. Yeah, it is struct node, int key, int value, and struct node next. Very good. Absolutely right. I'm Rohan. So this is that node. Now, initially, before we start adding chains in our open chain, right? We need to initialize this particular array. Why are we bothered about this array? Because when we are passing the key to the hash function, that hash function is going to return one index of an array. So therefore, the starting point is that we have to initialize this array, right? The starting point is we have to initialize this array. Now obviously the assumption to be made is that there are no keys in the chain. There are no keys in open chain not corresponding to index 0, index 1 and index 2. In none of this there are any linked list. So that should be the basic assumption, right? So what we do is that at every particular index, right? At every index, if you see this particular structure of the array item, it is a pointer to an array, right? It's a pointer of array of structures. It's a pointer to array of structures. What is a array? Let me go back to the basic definition of an array. What's an array? Array is a collection of elements of similar data types stored in a contiguous memory location. The basic definition of array is what? Is a collection of elements of same data type stored in contiguous memory location. Now, what is the data type we are storing here, here and here? The data type we are storing is array item. And what is the structure of this array item? The array item has got two elements. One is struct node pointer head and the other is struct node pointer tail, right? The fact that it is struct node pointer head, and as Rohan has said, or Rohan has given, that this struct node, see the chat window, see the struct node, the first element is int corresponding to key, the second element is again int data type corresponding to value, and the third element is struct node pointer next. Why? Because this is a linked list. This is a linked list. So the third element, that is next, has, if the moment we start building the linked list, it has to be, the next has to have the address of the next node, right? And the key and value, you know that they are for the search, insert, and delete operation. So this particular structure is here, right? Every here, here, and here are these structures. So the initialization process, this has to be made null. The tail has to be made null at index 0. Similarly, at index 1, head null, tail null. Similarly, at index 2, head null, tail null, right? So this head has to be made null and the tail has to be made null, right? What is going to be over here is this struct node. What Rohan is saying, int key, struct node, first element is int key, second element is int value, and the third element is struct node pointer next, right? Who is it? Harihara Bogaram. Am I clear? Right, right. So this is what this has to be replicated. So we have to set it in a loop. We have to set it in a loop, and in that loop we have to make this null, null, and null. Right. So how to make it null? See the code. See the code. So in the main function, the first method, before you display the menu, the first method which should be called is this. Right. See the method. Initializing hash table. Initializing hash table. I'm taking I as 0. For I is equal to 0, I less than max. That max is what? This max is going to be? Any of you? This max is going to be? The size of an array. Very good. It could be 2, it could be 7, it could be 10, depending on what division, percentile division factor you have taken, right? So I is equal to 0, I less than max, I plus plus. Suppose it is 3, array of 0, right? Head is equal to null, tail is equal to null. Are you getting my point, students? This head at 0, I made it null, tail also I made it null, right? Now I plus plus, so I of becomes 1. So at array of 1, head is null, array of 1, tail is null. Again I becomes 2, at array of 2, head is null, array of 2, tail is null. And I'm displaying it also. I'm displaying it also. So this is going to result something like, if I take the output of this, what is this? Plus I is equal to 0, that is printed here. Head percentile, right? Array 0 of head. Since I have initialized to null, in the output, in the output you won't get NULL, but you will get 0 in any of your compilers. That is, take it Turbo C or take it your Dev++, right? So that's how this head, this percentile is corresponding to 0, and tail is corresponding to this array of 0 of tail. It corresponds to this 0, right? And suppose this is your array at index 0. Under the head you are null, under the tail you are null, and this is how you are populating the entire array. Students, anybody is having a doubt, please come to the chat window and clarify your doubt. This is the starting point of your open chaining code. Initialize the table, and this is the table corresponding to this 0. I am placing it as null. Yeah, somebody definitely will have a doubt. Please feel free. The more you clarify, the better you will understand. And my ultimate aim is that each student of this class should get selected in the dream company, your own dream company, which may be after maybe 1.5 years from now. When you come to 3-1, 3-2, the interview process will start, right? Somebody who can very comfortably work with the linked list, his logical thinking, I can definitely say out of 10, the logical thinking is definitely 7 or 8, or if not more, if not more. So you should be able to play with this linked list like how you have been playing with variables int x or int I is equal to 0, I less than 10, I plus plus, and you have been setting the for loop as if at the back of the palm you have that logic. So in the similar fashion, you should be able to play with the linked list, and it should be as comfortable as you have been setting int I is equal to 0, I less than 10, I plus plus, and working on it. So instead of int I, now the struct node pointer should get replaced. So you have raised your level of logical thinking. So since the chat window is silent, I assume that all of you have understood this code. And this code is exactly what I'm going to share with you. So when you execute this code, you will get the same results. So understanding will be further better when you start reading the code. Now let me move next. I would like to insert 6, right? I would like to insert 6. Now the interaction has started. The user has given the key as 6. We know the percentile factor is 3. We know that the percentile factor is 3, right? So 6 percentile 3, index 0. Very good, Atal. Yes, yes, 6 percentile 3, index value is 0. So now we have to do something at index. Point number 1, what we need to check, there are 2 possibilities. Now we know that it is going to go to the index 0. Now at index 0, there are 2 possibilities. What are those 2 possibilities? Possibility number 1, possibility number 1 and possibility number 2. Linked list already exists. Good. Head is equal to null, or you mean head is equal to null or head is equal to tail. Okay, Rohan, I'll take it that way. Null or non-empty. That's also correct. Bhavana already occupied. That's also correct, Bhavana. Yeah, right. Good. So you have started understanding that at index 0, either there is already an existing linked list. If there is no existing linked list, that initialization function which we had called has already made it null. So the fact that it is null means I can add a linked list at that index 0, right? Correct. So good. So we'll take it from that particular point. Hence, add a node with data 6 at list of 0. At list of 0. A chain of 0 or list of 0. In the code, I have taken it as list. In the code, I have taken it as list. So I want you to also get familiar with this particular name as list. L will be small. By mistake, I kept it as capital, but L is small, right? So at list of 0, we need to check, right? Another 2 possibilities. The previous state at list of 0 was this. The previous state of list of 0 was this. So now, when the user has given 6, I need to add a linked list here. So right. So this, as I already explained, the array of pointers of structure, array item type, right? This entire array, and corresponding to in the linked list, what I have struct nodes. I have struck nodes. Yes. Now head and tail. I'm replacing that with the actual fact, that is head and tail. Since it was null and since the key has mapped to index 0, since the key has mapped to index 0, so I should have a key as 6 and assume that my value given is 6666. Assume that the key passed is 6. 6 percentile 3 has resulted into index 0, and at index 0, since it was null, so what I did, I added 6 value this and next of null. Why next of null? Next is equal to null. Yeah, I can. Yes, as Nikhil is saying, if you say it's the last node, as Bhavana is saying, it's the only node. That's also right. Or somebody can say only one node, right? So all of you are right. First, either you say first node or last node because it's only one node. Either you say last node, you are right. Is the first and the last node, you are right. The only node, you are right, right? So since it is the first and last node, will you agree with this fact that head, which was initially null, should be the base address? Also, the tail should be the base address. If I say head is the base address, if I say tail is the base address, both ways I am right. Both ways I am right. But at every time, this particular element should always keep a tag of where is the head and where is the tail, because there is only one node. Therefore, head and tail both are pointing to the same base address, right? But as you start, if at all you add a node here, head is going to remain at the very first, but the tail is going to move. The tail is going to move. Are you understanding this, students? Any doubt? Head is also here pointing to the base address and tail is also pointing to the base address. Assume that the base address is 0. How do you get the base address? Because first and foremost, we create an isolated node, populate the key, populate the value, and initialize the next with null, right? And return the base address. Now that we are storing in the pointer head and also pointer tail for the first time. Yes, clear so far? So only one element, head and tail both have to point to the same base address. Both have to point to the same base address. Okay, now let us take one more case. The key given is 12. The key given is 12. Now you know that the division factor is percentile 3. What the index? Yes, always Rohan, Nikhil, Bhavana, only these 4-5 students are responding. Are others are also understanding or no? Yeah, good. Right, good. So we are getting for index val, we are getting index to the same value, right? We are again index. Now what is going to happen now? Now this is the case of Pranav. This is the case of, can I ask Pranav? Collision, right? Because at that index value already one node is there, so the collision has occurred. Now when the collision has occurred, what is to be done? I need to append, right? I have added a linked list. I need to append a node to the existing linked list. I can't say, well, I'm sorry, well, I cannot accommodate this key because already the place is occupied. I can't say that, right? So collision has come, collision has occurred, as all of you are correctly saying, because both key value 6 and key value 2 are indexing to 0. Now the collision has happened. Now the open chaining, now the concept of open chaining will come into play. Now here it was 6. The next, in the previous slide, you have seen this was pointing to next null. Now because 12 has come, I'm appending this 12. I'm appending this 12. So the base address of this particular node will get copied here. And the next of 12 is going to be null. Next of 12 is going to be null, right? So earlier this was the situation. The head was pointing here, the tail was pointing here. The fact that the inserted key is 12, unfortunately or fortunately, it has resulted into 0. I have to prepare and add a node here. When I add a node, right, the head continues to point at the base address of the first node. No problem. What is to be done is we have to manipulate tail. Now, how will you, before we start assigning the value to tail, we have to build the linked list also. Now, how do we build the linked list? Right, tail is equal to curve. Fine, Nikhil. But this node also should be in the linked list fashion, no? So this null has to be replaced with what? Because I have started building the linked list here. This null has to be now replaced with something. You can't just store here without doing anything over here. Base address of curve, tail of next is equal to curve. Presently tail of next is equal to curve. That's good. That's also I will agree, because presently the tail is here. So tail of next is equal to curve. This is whatever is curve. So this gets replaced with this, and then tail is equal to curve. Right? Very good. So both are pointing here. So what we need to do? Before that, one more job is required to be done. What? Suppose the user, now you are clearly seeing that 12 has been passed. Is it not possible that the user will give 6 again? Can you rule out that possibility? You cannot rule out that possibility, that the user has already entered 6 as the key. The user again tries with the key as 6, right? You will come to the index over here, and if the 6 key is found, then you have to do something else. So first let us check whether the 6 key is found or not. If it is not found, then I get find index equal to minus, right? That is the key not found in the existing linked list. Which is the existing linked list? There is only one node, and 12 is there, and 12 is not found in the existing linked list. If 12 is not found in the existing linked list, as some of the students are saying, tail of next is equal to curve. Very good. Instead of tail of next is equal to curve, what I am saying, array, because array index is what? 0 dot tail. Students, are you understanding this? Is equal to item. What you are saying, curve, I am saying this as item. Desai, Toshniwal and Rohan, what you have said, curve, I am saying this as item. Are you okay? Right. So array of 0 of tail is equal to item, right? And array 0 of tail is equal to item, right? So this first has to replace with this, and then this tail has to move forward, right? So what we do, going by this logic, first tail, that is tail of next, we made it as item, which is this, and second tail is equal to item. So this tail has to come here. The tail is this 12. Assume that the value is this, and this is null. So the last job, that this tail has to point here, and that is what exactly Rohan, Toshniwal, Desai and others are guessing. Students, are you okay with this? First, if you understand the algorithm, I have not yet touched the code. but I'm touching some of the if conditions. I'm building your algorithm first. If the algorithm is clear, any clarification? If 6 already exists, the find index will never return to -1. Find index is equal to -1 only when the key in this linked list is not found. Key in this linked list is not found. Right? Can you explain again? Okay. See, the present state is this. The present state is this. There is only one node. The node is 6. Right? The key at this node is 6. Now the user wants to insert one more node. The user wants to insert one more node, say 12. So 12 percentile 3 results into index 0. Right? So I'm going to definitely come over here and point number 1 to find out whether 12 is there in this linked list. Whether the key 12 is there in this linked list. Right? So I call a function to find the key 6 in this linked list. Right? If the return value of that is -1, means what? The key 12 is not found in the existing linked list at this particular place at index 0. Since the key 12 is not existing in this linked list, so what I need to do, I need to append. Append means what? Add this new node with the key 12 and value as 1212 at the end. Append means what? Adding as a key at the end. So I added the key at the added the node at the end. Because before that I have already checked that the key 12 is not there in the existing linked list at index 0. Right? So array of 0 of tail, array of 0 at tail, which is a pointer. Right? So what is tail is pointing here. Right? Array of 0 of tail is here, of next is equal to item. Item is what? This is that the new node which I have created, which is having the key as 12. Right? So this starts pointing here, which is 12, and assume that the value is 1212 and this is null. Now the second job which have to be done, that the tail should always point to the last node. In the existing linked list, the last node is this. So the tail should be pointing here. So that's what we are doing. Array of 0 of tail is equal to item. What is the item? Base address of this particular newly added node. So we start pointing it over here. Raghavendra. Or anybody else. Raghavendra or anyone else who has not understood so far, please shoot your doubt. Right. So the chat window is silent, so I'll go further. Now the user wants to add 10. So 10 percentile 3 resulted into 1. Right? So these are already there. So I go to index 1 and add a node here. Right? So this is how the open chaining algorithm should work. This is how the open chaining algorithm will work. Right? So in this algorithm, if you understand the algorithm, you are already now understood how to create linked list. Right? You know array of pointers of structures. Right? The point array is of struct node array item, which is the array of pointers. Right? So let's see the algorithm. Algorithm point number 1: declare an array of linked list with a hash table size. In the previous example, the size was 3. Right? Second thing, initialize an array of linked list to null. You already done that. Next point, find the hash key. You have passed 6, then you pass 12, then you pass 10, right? Send the find the hash key means what? The hash function you have to pass the key. That hash function will result into index. Send it as parameter to h of key. What is h? That hash function. In our case, key percentile 10. So it is going to return as a 0 or 1 or 2, right? This you have already seen. For example, I is equal to h of key. I is equal to h of key. What is this I value? Either it is 0 or it is 1 or it is 2. Yes, Raghavan? Raghavendra, anything? That hash table is this only. See, this hash table, the array, this array is struct node array list, which has got two elements, head and tail. And the nodes are with this structure. The hash table, that is the corresponding to index, there is a base address. Corresponding to this index, there is a base address. So the array of array link type are maintained here. The structure I gave you, no, in the previous slide. This one. This particular array is going to have array item, which, and this is the normal linked list, which you have already seen. Raghavendra, have I answered your question? This array of pointers, so they have, it has got two elements. One is the head and tail. So this head is going to point to the very first node in the linked list. The tail is always going to point to the last node in the linked list. Yes, Raghavendra. Have I answered your question? Single linked list. Single linked list. Yeah, single linked list. Okay. Right. Now, if list of I is 0, if list of I is 0, there's one possibility, then you are going to add a linked list at that index, right? If list of 0 happens to be null, at 0th index, we are going to start adding the linked list. Okay? Make list of I point to the key node, right? The first node as the head node. If it is else means what? When it will come to else, the fact that it is else means this condition is not met. Means what? Yes, students? Some of you are trying. There is already a linked list. There is already a linked list. There is already a linked list means the collision has occurred. Collision has occurred. So collision resolution as per open chaining is what? As per open chaining, the collision resolution is append a node at the end. Append the node at the end. Append the node at the end, right? So else means what? Else means that the collision has occurred. The collision has occurred, then you have to resolve. Insert the node at the end. insert the node of the at the end of the existing linked list of 0, right? So this is the basic algorithm. Now, if you have understood the basic algorithm, I'll go further, right? Now, uh, okay, so your struct node, as previously I think Rohan had said that int key, once previous slide, okay, line 5, yeah. See, you have last in the example which we have taken, the key we have passed is 6. The key which you have passed is 6. So h of key, that is 6 percentile 0, has returned an integer value. That integer value I am storing in I, right? That integer value had resulted into 0, 6 of 6 percentile 3, right? Then I go to the array at list of 0. When it was initialized, it was null. When it was null, means what? At index 0, linked list does not exist. At index 0, linked list does not exist. So what I did, I added the node at index 0, the head node or the tail node, whatever way you call. So I have added a node at index 0. Now again I pass the key as 12, sent it to the hash function. So 12 percentile 3, it has resulted into 0 again, right? So presently list of 0 equal to null, false. Why? Because the node 6 is already existing. Means what? It has come to else. Means what? The fact that it has come to else means what? Collision has occurred. How collision has occurred? Because I wanted to add a node here, but one node is existing. That's what is collision. So when the collision has occurred, I have to do open chaining way of collision resolution. See the title. The title is collision resolution and the method used is open chaining. The chain, the linked list chain is open. So what I need to do, the node with key 12 has to be appended. So when I come to else, insert a node at the end of the linked list which is at index 0. Yogeshwar, am I clear? Is your doubt clarified? Okay, so let's go further. Now I'm part by part, I'll start talking about the code. This code I'm going to share with you, and when you copy in your dev C++, you will get the same code. So let us be familiar with that. As Rohan had suggested, same structure, struct node, int key, int value, struct node pointer next. This is my node. This is my structure of the node. So at the key, some key value, some value, and always when we create an isolated node, we initialize this to null. And once we join it with some in the linked list, then we accordingly modify this value. Next, I'm keeping int size because sometimes they ask determine the number of elements present in the hash table, right? All the elements at every linked list corresponding to 0 index, 1 index, 2 index, there are individual linked list. So if there is a requirement that in every total number of nodes in all the linked list is the size of my hash table, right? Is the size of my hash table. So to count that, I'm declaring one size as one variable, max 10. Now you must have guessed, students, max 10. So my array size is good. My array size is 10. My array size is 10. So we are making a basic assumption that the array size is 10 means what? The key is going to be percentile with 10. The key is going to be percentile with 10. That means that I am to get 10 starting from 0 to 9. I am going to 10 indexes. Right. Correct, Durga Prakash. I am going to get from 0 to 9, that is 10 indexes. Now the second structure, the two structures we have to form. The second structure is struct array item struct node, pointer of this array, this structure type, head pointer. Struct node tail, again a pointer of this. So they are the two elements. Head pointer to the head pointing to the first element in the linked list, and tail pointing to the last element in the linked list. So we have to continuously monitor. And what the name given? The name given to this array is array itself, right? It's a pointer. Students, the array in a conventional manner you can say int of array and then put a size. Or the other way of what is an array? The array name stores the base address of the array, right? The fact that the array name stores the base address, and we are talking in terms of address. So I can also, instead of declaring the in a conventional manner array within brackets size, I can replace that with a pointer. Are you okay with this? Are you understanding why a pointer is a representation of an array? Hello? Yes. Other students, please brush up your C. Is how do you declare an array in a conventional manner? Suppose it's an integer type of an array. We say int array, and within square bracket we put the size. Yes. So in this conventional manner, the name of an array or the value at array index 0 is nothing but the base address of this block. Right? So the array name stores the address, right? A pointer also stores the address. As per the definition of the pointer. Please brush up your pointer knowledge. Okay. Since the pointer stores the address, therefore straight away I am declaring it as a pointer array. What is the data type of this array? The data type of an array is this array item type. Each element is going to be array item type. Means each element at every index 0, 1, 2 up to 9 is going to have two values. One is the head and the other is the tail. Lot of students are wanting to have clarification. Someone at least keep shooting your question. Sanjana, instead of pointer we can do it in that way also, sir. If we do it that way, your logic will be very big. So ideally, let us handle it in the pointer manner, because pointer handles it in a dynamic manner. Sanjana, because there are two pointers stored at every index, so it will be more convenient to use a pointer logic compared to your conventional manner. What is this? At that index, at every array, we have two elements. What two elements? Both are pointers, right? So since we need to dynamically handle pointers in a conventional manner, it will be very, very difficult. Therefore, we are using this pointer. R. Sanjana. Right. So this is that. Yes, Akhil. when we check the size of an array, does that include linked list also? Uh, no, the size of an array is going to count only the nodes. The size of an array, the size of a table is going to count nodes, but the size of this array is 10. Nikhil, when we check the size of an array, does it include linked list also? No. When we are checking the size of an array is 10, but the size of the hash table could be anything. It would be less than 10, it could be hundreds, it could be lakhs. So this size variable which I am declaring, this is going to count these nodes. That's the size of the table. By size I mean memory taken. When we check the size of an array, we will not be able to know how much memory is occupied, Nikhil, because the size of an array are going to store the pointers to the individual linked list, the pointer pointing to the beginning of the linked list and the end of the linked list. It will not, the size of your array will not give you the memory required for the existing table. To some extent, the memory required, when I come to know the size multiplied by memory used by each of the nodes, that will give you the memory taken. Nikhil Reddy. First, let me finish with Nikhil Reddy. Nikhil Reddy, the size of the linked list, the size of an array. The array we are creating only to get to the linked list. Through the hash function, we are coming to a corresponding linked list. Now there are 10 linked lists which we are going to manipulate or we are going to manage, right? So the size of an array could be 10, but the number of nodes in my table does not mean that only 10 nodes will be accommodated. Each linked list can accommodate infinite number of nodes. I think Nikhil, I have not answered your question since you are not responding. D. Nikhil Reddy. The size of an array is 10. We are limited it to 10. My network is not stable, sir. I could not hear you. I will clarify in next class, sir. Are you able to hear me, Nikhil? Nikhil, can you hear me now? Has your network restored now? No, I don't know. Okay, fine. I'll clarify it in the next class, Nikhil. Okay. Yeah. Anybody else? Totally breaking. Is my voice breaking for all or only Nikhil Reddy? Is my voice clear, students? Yes, clear. Or maybe it's a local issue with Nikhil, unfortunately, because Nikhil participates in the class and unfortunately he is not able to hear me. Anyway, thank you, students. If it is clear to now, what I'll do, I'll continue it up to 2:30 because I want to come to some conclusion. Because today we'll not have a quiz or clarification. Let me continue up to 2:30 so that I can finish at least one concept. Okay. Okay. So let me go further. So we have two structures. One is corresponding to node, key, value, and next. This is a linked list. Each node of the linked list. Now this structure we have in the array corresponding to this. So this pointer is both are of struct node type. This head as well as tail, as you are seeing it over here, are struct node type. So they will have the base address of this node only, struct node type node only, right? And this in the array at every index, that is 0 to 9, at every index you have something like this. So array is a collection of elements of struct array item types. The array which we are building is a collection of elements of struct array item types, which has got two elements, head and tail. Okay, so going further, now hash code. Now let me talk only about hash code. Hash code is a simple function. Name of the hash code function is hash code itself. It takes one parameter, key, and it returns key percentile max. What is max? We are assuming 10. So if I pass 22, 22 is going to be first passed to the hash code, 22 percentile 10. So the return type is 2, right? So this hash code, the h function, what I was talking about in the previous classes, h of key. So the h I have replaced with hash code, and key is key itself. So if I pass this key as 22, the key is going to be 22 percentile max. Max we have declared as 10. So 10. It's going to return one integer value, which is going to be 2 in this case, right? So I hope you have understood this function, hash code. Very simple. So whenever I'm invoking, whenever I want to insert or find or delete, I first need to call this hash function and come to the index, come to the particular index. Why? Because at that index, I may have to insert, I may have to find, or I may have to delete. Now I am not remembering. I'm thinking. I think it is Meghana who had asked me. That why are you considering the worst case? Why are you considering the worst case? At that time, who was it? Was it some Meghana? I think so. No, sorry, it wasn't me. Somebody was talking to me. I don't remember. I was considering why we do this kind of a collision resolution. That time I was trying to explain you the big O notation. And in the big O notation, I was mentioning that we always consider the worst case. We always consider the worst case. So, I don't know, whosoever. It was Gayatri, is it? Okay, sorry Gayatri, I forgot your name. So, that is the time I was trying to explain. Now, by this particular technique, what we do, when we hash the code, straight away, we definitely come to the foot of the linked list. That is the starting point of the linked list, right? So this is the technique. This is the hash code technique by which we definitely come to the correct index of an array, where we start either inserting, searching, or deleting. Inserting, searching, or deleting. So this is the hash code I'm talking about. Going further, 1 percentile 10 is 1, 22 percentile 10 is 2, 777 percentile 10 is 7, and the fact that 11 percentile I have put in red, this is the point the collision has occurred. Why? Because 1 percentile 10 is also indexed to 1, 11 percentile 10 also has index to 1, right? Therefore, this is the place where the collision has occurred. So this is the place where the collision resolution using open chaining is to be used. Using open chaining is to be used. Okay. This I have already explained it to you. So when you execute this code, you are going to get the output something like this: I0, head 0, 0, head 0 means null, tail 0 is null. So initially we are making an assumption as null, right? So the hash table, what we have seen previously, only up to 3. this is going to go up to 9, that is 0 to 9, it is 10. So when this code is called or this function is called, your array has got initialized with head as null at every index. At every index it has got initialized to null 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 up to from 0 to 9. Going further, students, next 15 minutes 100% attention I want. Next 15 minutes 100% attention I want. If I can finish in 15 minutes and if there are no doubts, I'll be the most happiest person that I have communicated the insert logic. Now when I call the insert function, I am passing the key and value, right? When I call the insert function, before that I'm taking from the user key and value. For example, you have seen the key, say key is 100 and the value is 1111, say, right? Then these are the function declarations. These are the function declaration. One is get element, which is going to return a struct node type. Other is a remove element, which is going to return void. Init array, this code you have already seen, and get element. Get element, this has come second time. Okay. So let us focus on the insert function. I want 100% attention, students. Very crucial to understand. If you understand insert logic, you will understand delete logic also, you will understand search logic also. So I want 100% attention. That doesn't mean that I'm saying that I'm going to repeat only once. Wherever you don't understand, please use the chat window. I'll repeat it again. But let us concentrate and try to understand in next 15 minutes. Now I declared two local variables I and this float n. Now what am I doing here? Int index hash code. Suppose I pass 100. I pass 100, right? It's going to result into, when I have called the insert function, I have passed key as 100, value as 1111. Now just now you have seen this hash code function, right? So hash code was 100, key is 100, 100 percentile 10, resulting into 0, isn't it? This is what your hash code. I pass 100 as the key. This key was 100, 100 percentile 10, return is 0. So your this value is going to be 0. This value is going to be 0. So extracting head node of the linked list at a given index, right? At a given index. So before this was done, I have already initialized the complete array with nulls. Students, I hope you don't forget that point. Now struct node, I have created one pointer list of struct node array index of head, right? Creating an item to be inserted in the hash table. Presently the hash table is looking like this. At index 0 I have not taken up other ones because it has already indexed to 100 as indexed to 0. So presently head is null, tail is also null, right? So has the collision occurred? No. If the collision has not occurred, what am I expected to do? At this particular point, the head value should get replaced with the cur node, or which I am calling as item. The tail value also should be having the base address of item, right? So that is that item. What is that item? Struct node type. What is the struct node? The struct node is, there are three elements: key, value, and pointer to next, right? So that is stored in the item pointer. Now this item pointer I am populating. Item of key is this key. What is this key? 100. So your item of key is 100. Item of value is equal to value. What value I have passed? 1111. So this is double one, and item of next is equal to 0. So key is 100, value is double one, next is null. So far clear up to this particular stage? Up to this particular stage, and I'm making an assumption that this item, the base address 1000, this is base address. So when I say item dot key, reference to this base address is going to come into this block and extract my 100, right? So this item is equal to 1000 means this 1000 is nothing but I'm making an assumption that the base address of this is 1000. Okay. Next. Now list equal to null. What is in the list? What is in the list of 0? Is it null? Yes or no? No. Vishnu says yes. Bhavana says no. Desai says no. Why no, Desai? This is the first time we are trying to add the key. Before that, we had initialized it. So at every index we have nulls. At every index we have nulls. Okay. 100 we are going to add. Okay, this side. Understood. Meghana, understood? I think you got confused when I said 100. Okay, good. So presently this is the state. So the list is list of index at index 0. It is null. Are you getting my point? Again, what is in this list? Array of 0, 0 of head. Array of 0, 0 of head is null. So in this list I have null, right? So list equal to null, true. List equal to null, true, right? So I print enter in the if condition, inserting %d key and %d value, key and value. What is key? This key. So you will get a printout saying that inserting 100 key and value 1111, just as an interactive kind of a logic. Now array index. What is the index? Index is 0. Array index of head is equal to item. Someone, can you tell me what is going to be the output? What modification will happen here and what modification will happen here? Array index head, presently it is null, but now I am taking item. What is an item? 1000. So both, right? When this statement gets executed, array index 0 of head is equal to item. Presently the item base address is 1000. So this gets replaced with 1000 and this also gets replaced with 1000. Why 7000, Nandini? Yeah, you are corrected yourself, right? So good. So you students are with me. So now my index 0 has got a linked list with only one node, which is here. So this is pointing here. This pointer is also pointing here because there is only one node. Now I have added the node. So what will happen to the size? Nikhil Reddy, are you hearing me? Yes, Rohan, 1. The size has become 1. Yes. So the size plus size which was initialized to 0. So I have started counting how many nodes are there in the table. I'm not talking about one linked list. Table means what? Now there are 10 linked lists. And when I am counting the size, I'm counting the size of the whole table, that is in all the 10 linked lists, right? So I'm taking care of this size plus. Nikhil Reddy, are you able to hear or you are still network issues? Nikhil is not responding. So sorry. He is one boy who is so active in the class. Unfortunately, he is not able to hear me. Anyway, someone can help him out from his class. Right. So the first criteria, when this was resulted into null, I have inserted one node. Any clarification? I'll move to the next slide. I still have 7 minutes. Any clarification regarding the first if condition? We are doing insertion job. Basic assumption was there was not a single linked list. That is what init function has done. The very first node which we are adding is having the key 100 and the value 1111. Okay. Now the chat window is silent, so let me proceed further. Okay. Now, when will I come to the else block? If is false. When can be if is false? Already occupied, right? Already occupied. Good. So first we are considered when very first node was added. So this was the state. Now I'm starting with else. This is a continuation of the previous code. This is a continuation of the previous code. Right. Right, Raghavendra. So I will come to the if block when I have got indexed to 0. I got indexed to 0, and at index 0 already a key corresponding to 100 was there, right? So list equal to 0 is false. List equal to 0 is false. Then I am coming to the else block. I am coming to the else block. Now again, I have to check two conditions. I am trying to find out how many students are keenly listening to me. Why I am calling this find list key? But before that, let me display this function find. This function finds given key in linked list, return index or returns -1 in case key is not present. When I am calling this function find, which is this function, right? What is the job of this function? That this function finds the key in the linked list. Which linked list? Presently at index 0. At index 0, the linked list which is there, in that linked list, am I finding a key? Right? If it is there, it returns -1. It returns the index. If it is not, it returns -1. Okay? Yeah. So now suppose I have passed 10. What is list? List is that previously already there. This list is here. List is basically pointing here, right? It has got these two things. So the first parameter is that list and the second parameter is key. Now assume that this key is 10. There is one variable called return value, short form ret val, initialized to 0, struct node temp, right? Now what is the current state? The current state is this, right? There is one, right? This is pointing here and this is pointing here. Now I call this function and the key pass is 10. The key pass is 10. Students, the present state is this. The key pass is 10. So I come to the else block. In the else block, I call the find function. Now let me talk about this find function. The list, right? It is pointing, the list is present value is 1000. Okay, come here. Temp is equal to list. I'm creating one more pointer, temp, which is equal to list. So this temp equal to list means what? Since list is 1000, temp also will be 1000. Yes? Temp not equal to null. Presently temp is 1000. It is not null. So I enter the while loop. I enter the while loop. Temp not equal to null because temp is 1000. It is not null. True. Now what is the temp of key? How much is the temp of key now? Yes, Bhavana, Rohan, good, good, good. Temp. Temp is 1000. Temp of key is 100. Right? Temp of key. What is the key? What is this key? This key is 10. Right? Temp of key 100 equal to key. False. It won't enter here. Temp is equal to temp of next. What is temp of next? Null. Right? Temp is equal to temp of next. Temp has become null, but ret value has become 1. Ret value has become 1. I go to the top of the loop. What is temp now? What is temp now? Null not equal to null. So false. False means what? I come out of this while loop and return -1. I come out of this while loop and return -1. So, right, correct. Durga Prakash, correct. So, temp equal to null. Ret value has become 1. Null not equal to null. That is temp not equal to null, false. And ret has become 1. And I now return 1. Return what? Return -1. So what is going to be an index? What is this index? 0. Tail. At 0, index tail pointing to 1000. What is this? Going to be replaced by item. What is item? This is that new node, the isolated node, right? So this next, the tail of next is going to be replaced with the item, and that item is this value. So this next is going to get replaced with 2000. Are you agreeing with me? This is a base address is 2000. This is 2000. Next step, array index of tail is equal to item. Now this array index of tail, array 0 of tail, this also needs to be replaced with 2000. So this gets replaced with 2000. And then size plus plus. Now this was when node was 1. This was when node is 2. This is when node is 2. So the size becomes 2, and I am in the else block, means what? Collision has occurred. But first thing I found out that the key is not clashing. The key is not clashing. Because the key is not clashing, I need to append this node to the existing linked list. I need to append this node to the existing linked list. And that is what exactly I have done. The head continues to point to the base address of the head node. The tail continues to point to the base address of the tail node. And these two are in the linked list form because this node's next is having the base address of the next node. Students, have I made myself clear? Anybody? This is a complicated logic, but interesting. That's why I have tried to put as much animation as possible. If all the students, if I would have been in the class, I would have been the most happiest person to teach you in the class, because I would have looked into the eyes of each student and I would have focused on the student who is not understanding. With my experience looking into your eyes, I can come to know whether you understood or no. So my basic idea is that every student understands, but unfortunately I can't see you. Yeah. See, return -1. It is like this, Pranav, that we have started with when we called the find list, right? The list was having base address 1000. List was having base address 1000. So when we called the function and the key I'm passing is 10, key I'm passing is 10, right? So when I go to this find, what has happened? I have created one. I have first initialized a local variable called as return value, ret value initialized to 0, and I have created a pointer of struct node type. This is a node. So temp is also struct node type and list is also struct node type. So temp is equal to list. List is presently storing the base address 1000. So temp becomes 1000. Now temp not equal to null. True. 1000 is not null. True. So I enter here. If temp of key. What is temp? Temp is 1000. 1000's key is 100. Equal to key. What is the key passed? 10. False. Since this is false, I come here. Since it is false, I come here. Temp is equal to temp of next. Where is temp? Here. What is temp of next? Null. Right? So the temp value has become null. Temp value has become null. I go to ret value and increment it by 1. So this has become 1. This has become 1. Now I go to the top of the while loop. Null not equal to null. False. When null is not equal to null, false, what I do, I come out of the while loop. When I come out of the while loop, what is there? Return -1. Return -1. So this find function which was called has returned 1 -1. Has returned 1 -1. So my if condition is that find index. What is this? -1 equal to -1. True. Since it is equal to -1, true. The key not found. Which key not found? The 10 key which you had sent, which had indexed to 0, and an existing linked list was having 100 key but not 10, right? Therefore, I have entered the if condition. Having entered the if condition, the existing node has to be appended with the new node, right? So array of 0 of tail, right? Array of 0 of tail of next, 1000 of next is equal to item. The base address of item is 2000. So this thing gets replaced with 2000. This thing gets replaced with 2000. Next step, array index of tail. That is this. Every time this particular structure keeps a tag of the head node and the tail node, right? So this also gets replaced with 1000, right? That is how I have built the linked list also, and at the array I have kept the address of the first node and the tail node. Then you will ask me, if that were the case, why are you doing this logic? Probably, Pranav, basic question is, why is this logic? When will this logic come into play? When will this logic come into play? Suppose the user has sent 100, the key is 100, right? I started with this, and the next key is also 100. Now, if the next key is 100, find index. Ret value is 0. Temp not equal to null, true. Temp of key is how much? 100. Equal to key 100. True. Ret value So 0. I pass 0 here. I pass 0 here. Right? So it is not going to enter this if condition. It is not going to enter this if condition. Pranav. Right? So this while loop is also equally useful. The while loop is equally useful. Suppose there is a clash and two keys cannot have the same values. That we have to maintain all the time. That we have to maintain all the time. So students, complicated code. Please, when I pass it on to you, go through it 3-4 times and try to do it yourself. I'm stopping the class. I'm not activating any quiz. Sorry, Shankar, if you are listening to me, I did not give you time to add. Shankar, are you listening to me? In the next class, we'll have the quiz. In the next class, we'll have the quiz. Okay. So I'm stopping now, students. Oh, yeah, Surya Teja. I did not send, no? Yeah, I forgot. Thanks for reminding. I'll do it today. Surya Teja, I will send the code today. Okay.